Hello, hello, and welcome to DevSecCon Germany. It's a part of the DevSecCon global community, an inclusive community that enables and helps developers to provide secure software. Today, we'll be joined by Mohamed to talk about the threat modeling to create a DevSecOps plan. Before we dive into that, just a quick introduction. My name is Sebastian. I'm a tech specialist working at Sneak, and I'm joined by Ardit.
Yeah, and I'm Ardit, a security specialist at ESET Germany. For anyone watching right now, head over to the YouTube channel to interact with our speaker, Mohamed, and ask any questions or share comments. Afterwards, the Discord server is the best place to interact with our speakers and fellow community members. If you haven't already signed up, you can find the link in our website, DevSecCon.com, and by joining the Deutsch DevSecCon discussion. And if you're listening to this session after the live recording, you can still ask questions on Discord and we'll aim to get them answered. Once the session is over, you'll be able to rewatch it in our website, share it with friends, colleagues, or hopefully both.
Cool. DevSecCon is brought to you by Sneak, and our aim is to create a vendor-neutral space to share knowledge and best practices around the industry. So that's enough from us. Without further ado, we're going to hand over to Mohamed. Hello, welcome, Mohamed.
Yeah, welcome. Thanks, Sebastian. Thanks, Ardit. So yeah, let me start by sharing the slides.
Fantastic. So we're going
to perfect. Okay, so let me maybe start from a bit of an unexpected place, which is like a linguistic phenomena called semantic diffusion. So this is the process by which a word gradually loses its meaning and start meaning maybe new things. The more it gets popular, the more it gets used. You can see this in like everyday words, like, for example, the word literally no longer means literally, but you can also see it for technical terms. One of the reasons this happens is that when a word starts getting used, specifically a technical term, at the beginning, it's being used by a small group of people with a very tight and precise definition. But as more people learn about it, we definitely don't we don't understand the meanings of words just from dictionaries or from definitions, but rather from the context in which we hear them for the first few times. So new groups of people start assigning new meanings and start using the word differently. And as it gets more and more popular, maybe sales and marketing teams start using it, and then it becomes a buzzword, as we have seen before. So the point is, the more you use the word, the more it becomes, the meaning becomes diluted. And that's why it's usually a very useful thing to revisit the original meaning and the original goal, specifically of technical terms. And usually you find a lot of good insight if you do that. And today my goal is to do that for the term DevSecOps. So as you can see, it has been used very well, like more and more over the past 10 years. And obviously DevSecOps itself is a derivative of DevOps, which has been even used more and more over time. So what I'm trying to argue today is that maybe DevSecOps did go through semantic diffusion and the original goal and meaning may have been diluted over time. So I'm going to maybe try and revisit that original goal and meaning. And in that process, I'm hoping to prove that threat modeling is what really puts sec in the word DevSecOps. So let me first introduce myself. My name is Mohamed AboElKheir. I am an application security engineer at Ironclad. I've been there for a year with the goal of building their application security program. And obviously, Ironclad themselves have the task of bringing contracts to the digital age as well. Before that, I was at AWS for 6 years, mostly doing application security reviews. And in my spare time, I have a blog called AppSec Untangled. The link have been added to the event for this one, and I can share it at the end if needed. This talk basically will be 3 parts. The first one is theoretical. Like I said, I'm going to explore the original meaning and goal of DevSecOps and how this is tied to threat modeling. The other part, or the second part, is going to be more practical, where we take like a sample application and we see some examples how we can actually use threat modeling to create the DevSecOps plan for it. And lastly, there are some key takeouts that we are going to be discussing, which basically you can go and apply in your organization based on what we are presenting today. So let's start from the beginning. So I think most people are tired from hearing the DevOps story. So maybe let me take a different approach and share my own DevOps story. So around 11 or 12 years ago, I was at the ops side. I was an operations engineer. and we were maintaining this application. We had Wednesday as the deployment day, so we only did deployments on Wednesday. And the deployment was 2 hours of manual work and downtime per environment. So like Wednesday, we had a team of like 3 or 4, and all Wednesday was spent on just deployments. This took a lot of time and effort. It was error prone. We had a lot of issues with it. And that's when we discovered DevOps. So we started using automation tools to automate the deployment, automate the testing, create alerts, let's say, if deployment causes, let's say, a spike in CPU utilization. We started using all of these new DevOps tools, and suddenly Wednesday became the best day of the week, because now we just click a button and we just track the deployment. Everything is automated, the deployment, the testing, and our life was much better. And obviously, like the rest of the story, you already know, now many organizations do multiple deployments per day, not just like one deployment per week, and everything is much better. And this takes me to the definition of DevOps that I prefer, which is it's a set of culture, tools, and processes to make software delivery fast, efficient, and reliable. And I want to focus on the goal here, which is fast, efficient, and reliable. We want to, instead of having like one deployment per week, we want to have multiple ones per day if we can. We want to reduce the effort needed per deployment. So instead of like doing it manually, we just click a button and track the deployment. And lastly, reliable, which is what I want to focus on for today's talk, because obviously with speed comes issues. So we want to make sure as we are deploying new software, we're not breaking things. And reliable means many things. Let's take, for example, 3 of these things: functionality, sometimes called stability, performance, and obviously the one that I'm going to focus on is security. So as we started deploying code faster and faster, we wanted to prevent issues from happening. And hence, let's say for functionality, you want to make sure that we're not breaking functionality, existing functionality, by new code. So we started introducing things like unit tests, integration tests, and even some other types of tests. And the passing criteria here was making sure that the tests that we have created are passing, so new code is not breaking functionality. And also we had some other metrics like code coverage to make sure that enough of our code is covered by these tests. Similarly, for performance, we had latency tests, and then obviously we were failing if the latency tests failed, and also load tests to measure throughput. And we also were monitoring some other related metrics like resource utilization and so on. For security, at the beginning of DevOps, nothing really happened. Like we didn't really automate anything, and hence what happened at the beginning of DevOps is that we had 3 teams working in different silos. 2 teams broke the silo and started working together, but security teams were kept in their own silo. So this takes us to DevSecOps. So that's when security teams started finding out about DevOps and started contributing to it. And the thing to note here is that security teams started noticing DevOps not to solve a problem like Dev and Ops teams did, but when they became the problem, because now DevOps enabled teams to move much faster, and now security teams became the bottleneck. So now, instead of solving a problem, we were trying to basically be part of what Dev and Ops are already doing, and just seeing what they're doing and trying to imitate it. So what we did as security teams is, okay, so they have this test that they're automating. We have some tools that we are already using in our like security review process, let's say. So let's just add them to the pipeline and see what happens. And obviously, like we were using things like CEST, DEST, SA, whatever. So we just added them to the pipeline and said, okay, let's make the passing criteria that we don't have any findings. And I think most people here already know that this didn't really work out well. And the reason this didn't work out well is obviously these tools were not built to run in DevOps pipeline. Like they were generated a lot of false positives, a lot of low severity and low importance findings that shouldn't be blocking anyone. Maybe like good to have, but not really that important. And as a reason, we broke the initial goal of DevOps. So DevOps' goal was making things fast, efficient, and reliable. But by introducing these tools, we were making things less fast and less efficient. And this obviously was a problem. So basically what we wanted to do as security teams is, in response to that, make things a little more efficient. So we started basically doing things like shifting left, running these things earlier, only blocking on critical and high findings, which makes things better. And most of what I'm reading in terms of DevSecOps these days comes to making these things more efficient. Now, obviously, this doesn't mean that the hit to speed and efficiency is not there. It is still there, but we are reducing it. But obviously, it is still there. And this, again, doesn't make our teams, the DevOps teams or developers that we are working on, they are not really happy about it. And they shouldn't be happy about it. But we usually tell them, okay, like, we need to make sure things are reliable. Part of being reliable is being secure. So this is a trade-off. You want to give away some of the speed and the efficiency to be able to be secure. But let me challenge this trade-off for a second. And let me do that by giving you an example. So recently, Metabase, this is like an open source software, if I remember correctly, is being used for data analytics and stuff like that. They had a very critical CVE, a pre-authentication remote code execution, so a very high severity one. And this was caused by a developer removing 2 lines of code in a PR for fixing an issue. I don't remember. But the point is, they had these 2 lines of code. And what these 2 lines of code were doing is basically clearing the setup token. So when you were initializing Metabase, you were using a setup token. And this setup token was what you used to authenticate during the initialization. Once initialization was done, you actually create an admin user, and now you start using that admin user, and the setup token was no longer available. But what the developer did here is remove these 2 lines of code. So even after initialization, the token was available. And hence, if your deployment was accessible from the internet, an attacker can go grab this token and use it to authenticate as admin to your application. And through some other details, they were also able to get some remote code execution out of that. So this is a very critical finding. And this was caused by just removing 2 lines of code. Now, going back to the approach that we had here, basically, the key point here, first of all, is that very small code changes could cause security issues. But the more important thing is that all of these tools that we just added to the pipeline, CEST, DEST, whatever, none of them with their default configuration could ever catch this. Like if you are using CEST, if you're using DEST, none of these tools can catch this really critical finding. And the reason is this is related to Metabase. This is a business logic thing that Metabase does. So no tool out of the box with its default configuration can catch this. So this means that the tools that we are adding, the security tools that we are adding to the DevOps pipeline, they have a very clear blind spot. All of the business logic issues and the ones related to each application, they are not catching that. They are just catching maybe known issues, known best practices if they're missing, and all of that is good. But these kinds of business logic issues, which, by the way, usually cause the most critical findings, they are not being caught here. And this means that even that trade-off is not complete, because even security here, we're not fully achieving that. We're gaining some security value, but we are not fully protecting against even some of the most critical findings. So again, to summarize, the current approach, in my opinion, affects speed, affects efficiency, and doesn't fully achieve security, in my opinion. And again, going back to the initial goals of DevOps, this basically is not good, because the goal of DevOps is to achieve these things. And this is why I mentioned semantic diffusion at the beginning, because now DevSecOps meant one thing to security team, but it meant a very different things to DevOps teams or developers in this scenario. Now, another word that I think went through semantic diffusion is security. So I think one of the reasons this is happening is we don't have a clear definition of security. Like I'm sure everyone watching this is either working on security or really interested in security. But if I ask everyone to give me their definition of security, I think everyone will have a different definition. And this is, I guess, one of the really important reasons this is happening, because for functionality and for performance, we had clear definitions, clear passing criteria. But for security, it's much trickier for us to do that. And this is why we had to use tools and depend on these tools to define security for us. And this caused that extra friction. So let me then go to the word security. Let's explore what does that actually mean. And maybe let's start from the dictionary definition of security. So if you just look it up, it is the state of being free from danger or threat. Now, what I want to focus here is the key word, which is threat. So what I'm trying to say here is that security in itself doesn't mean anything unless you know what you are secure from. If I say that this building is secure, this could mean that like it's secure from crime, theft or whatever, or it could be secure from natural disaster. So there are multiple things to be secure from, and unless it's clear from the context what it is secure from, security in itself doesn't mean anything. So in other words, you cannot say that your application is secure unless you know what it should be secure from. And this is what ties us to threat modeling, because the four questions that threat modeling tries to answer, first of all, is what are we working on? So the scope of the application or the feature. What could go wrong? So this is the threats, the things that we should be secure from. And what are we going to do about it? The mitigation. So the things that we are going to be adding to our application to make sure these threats don't happen, or that we are secure from these threats. And the fourth question we're going to get to in a moment. In other words, what threat modeling does, it defines what secure means for your application. If you know what you need to be secure from, then you know what secure means. And also, if you know the mitigations, so you know the things that always needs to be true for your application to be secure. So if you want to be secure from SQL injection, you always need to be using parameterized queries. So this mitigation needs to always to be true for your application to be secure. If you are using raw queries or whatever, then you potentially could be vulnerable here. So this is basically one of the key benefits of threat modeling. You know the list of things that always needs to be true for your application to be secure. Now let's go to the fourth question of threat modeling, and I think this is what really ties it to DevSecOps, because the last question is, did we do a good job? So this is kind of like a feedback loop question to go back and make sure we didn't miss anything. And usually when people discuss this question, they focus on two things. Did we catch all of the important threats? And do we have good mitigations? But I'm arguing that this means more. Like, for example, are the mitigations working as expected? So it's not enough to just document a mitigation in your threat model, but you need to make sure that this is working as expected. And you can do that either through a pen test or a code review or whatever, depending on the context. Now, the other thing is, will the mitigations keep working in the future? And this is key thing, because like we saw in the Metabase CVE, it was working fine, but a small code change broke everything. So it should be working in the future as well. And this is where you really need to have tests covering your mitigations. And this is where threat modeling ties with DevSecOps. So what I'm suggesting, instead of just taking tools as they are with their default configuration, putting them in the pipeline, what I'm suggesting here is using threat modeling as the core of your process, the security review process, and the core of your DevSecOps plan. So the way that this works, instead of just taking tools and putting them in different places in your pipeline, I am arguing that you should be starting with the threat model, taking the mitigations. So the mitigations are the things that always needs to be true for your application to be secure. And then for each mitigation, you prioritize obviously the mitigations that have the highest impact and the highest likelihood, and you create a test plan for these mitigations. And now basically you shouldn't, or you could use security tools, you could use some other tools, as we're going to see in the examples shortly. But the point here, it's not about the tool, it is about the mitigation that you are testing. And then the passing criteria is that these tests that you created for your mitigations are passing. And then you can create maybe another metric like mitigation coverage, similar to code coverage. So like you have, let's say, 12 threats and 12 mitigations. So let's say you're covering 10 mitigations with tests. So you have good coverage, let's say, in this scenario. So that's what I'm suggesting here. And this basically, in my opinion, makes things much better, because now we have a clear definition for security. And we are, first of all, covering, so we don't have these blind spots, or we are less likely to miss these really important critical findings, like the missing or the setup token not being deleted, because now if we have that in threat model, we will have a test for it. So we don't have these security blind spots. At the same time, we are only blocking the pipeline if a mitigation is broken. And the mitigations are the things that always needs to be true for our application to be secure. So we are only blocking for things that are reasonable for us to block on. So we're not just blocking on anything regardless of the context. So in my opinion, this approach makes things faster, more efficient, and also more secure. And this does align with the initial goal of DevOps, like I mentioned earlier. So let's see how this works in a software development lifecycle. So what I'm suggesting here is basically doing your threat modeling or your security review process in three main phases. The first one is during the design phase. So in the design phase, you basically define the design and scope, and you go through the threat modeling, define the threats and the mitigations. Obviously, you don't have time in this talk to go through how to do that, but I do have like a series about how to create a threat model and about all of that process, and the link have been added to the event itself. So you start with creating the threat model, and now you have the list of threats and mitigations. And now you can add two phases. One, once you have implemented this on a testing environment, let's say, where you actually verify the mitigations. So you maybe manually or through a pen test or whatever, verify that these mitigations are working as expected. And the last phase is the one that you implement by the time you deploy that to production, maybe before it, maybe just after it. But the point is creating tests to cover the most important mitigations, and these should be running continuously. So either you add them to the build pipeline or you schedule them to run continuously. But the point is your mitigations should be covered by tests, and these should be running by the time that you have deployed this application to production. And obviously, this last phase, phase 3, is the one that we are focusing on today. But like I said, the whole process is in the series about threat modeling I have on my blog, and the link for that is in the event link itself. So this way, if we do it this way, I'm arguing that this is the right way to break that silo between the security and dev and ops. And basically now you're working with the teams from the design phase, giving them clear testing requirements, giving them first of all, clear requirements about what needs to be always true, and then also testing requirements to cover these mitigations. So let's maybe take an example and see how this looks in a sample application. So besides the series I mentioned, I also have a Notion template for threat modeling. The link is also in the link for the event itself. And I do have a sample created using that template for this service that I'm going to discuss right now. It has all the threats and the mitigations and the tests and all of that. So I'm just going to take some examples in this talk, but if you are interested, just open the link and you can see more details there. So I'm going to take this file upload service as example. This is a very simple web application. You basically can register, you sign in, and then you can upload files, download files, or share them with other users. Very simple web application. I'm assuming you have like a front end, let's say using React. You have a back end running on EC2 instances that is using Django, Python for the back end. You have an RDS database, and you have like a private S3 bucket where the actual files are being kept. So that's more or less how the application works. Again, you'll find more details in the link. And now let's see how this works. So let's say we went through phase 1. We have identified the threats and the mitigations. So now let's take some of these threats and mitigations and see how we can create tests for these mitigations. So let's start with one of the most common ones. So bypassing authentication or bypassing authorization or unauthorized access is a very common threat that you have for most of your applications. And basically, we had two related mitigations. One of them is proper authentication and proper authorization. So authentication in this example is assumed to be through a session token cookie. So you have a session token, you keep that in a cookie, and this is always being checked to identify the user. And the authorization model here is that you cannot access a file unless you are the owner or the file has been shared with you. So that's the mitigations that we are expecting here. And let me ask you, what is the best way to test these two things, authentication and authorization? Now, I would argue that CEST, DEST, and all of these things are not good options here because, again, this is specific to the application that we are reviewing here. So you can do it using the session token. You can do it with other things. So you don't have it usually out of the box in any tool, a proper check for this, specifically for authorization, because usually authorization models are very unique to each application. And I'm arguing that maybe the best way to implement a test for this is not a security tool at all, but rather using a unit test or an integration test, something that your developers are already using. Developers are already writing unit tests and integration tests. So what you can do is just give them the test cases and ask them to add these either as a unit test or an integration test. So in this example that you're seeing here, I'm just using the Django testing framework and creating two tests, one for authentication and one for authorization. Obviously, we need more tests to cover other things, but the first test here is just testing missing session cookie. So if you don't have the session cookie, the one that has the authentication or the session token, then this is verifying that you are always getting a 401 response code. The other one is related to authorization. If you have a valid cookie, but if you are trying to access a file that is not owned or shared by you, you should be getting a 403 response code. So this, again, is a very simple test to write, but most of the time developers don't write tests for authentication and authorization unless you ask them to do it. So this is one of the things that should be coming as an output of your threat model. We need to have these tests, and you need to agree with your developers what's the best way to do it. Maybe unit tests, maybe integration tests, maybe we have, let's say they're using another tool like robot framework or anything like that. You can add them to the place that they already have their tests on, and you just need either to do it yourself or give them the test cases and they do it, or if you have a QA team that writes the test, you can ask them to do it. So the ownership can be discussed, but the point is having someone create these tests. Let's take another example. So another also common threat is CSRF. So we have some mutating routes here. Let's say the one that shares the file. What if someone uses CSRF to trick a user to share a file they own with the attacker? So this is always possible unless you have a CSRF token or a CSRF protection. So again, in this example, I'm assuming that we are using CSRFs or the Django's CSRF middleware. So this is just a decorator that you need to add to your routes called add CSRF protect, if you can see here. And obviously you can implement this using integration tests. You can just maybe run an integration test and make sure if you don't have the CSRF token, a valid one, you're also getting like a 401 or a 403 response code. But also you can use a security tool. So I wanted to use a different tool here, which is, let's say we are using SAMGRAP as our SAST tool. Now, SAMGRAP doesn't have a check for this. And again, this comes back to what I said earlier. It's not about the tool, but it's about the mitigation. So the mitigation here is having this decorator, and SAMGRAP, let's say, doesn't have this check. But it does have a feature to create a custom check. So for example, I can create this custom rule to scan for this decorator. So if this decorator is missing, I will get a finding, and obviously now developers maybe can get that in their IDE if they have the SAST running there, or they can block the pipeline or whatever. But the point here is that it's not about using SAST, it's about how you configure it, because now I'm configuring SAST to cover the mitigation that I agreed with the developers. Let's take another example. So another one here is unauthorized access to the bucket. So we had the customer files in the bucket. What if someone changes this bucket to become public? So I'm sure you have heard about many incidents where customer data was exposed because a bucket was moved to public for any reason, and this exposed customer data. So we want to make sure that this bucket is never set to public. So again, this is the mitigation. We want to make sure private bucket is never set to public. And there are many tools for us to do that. I also wanted to use Chekhov because they have that feature where you can write your own custom check. So let's say they don't have that check. What we can do is we can write this custom check for Chekhov, which basically tells if you have a bucket that has the tag type equals customer data and public read is equals to true. If you have these two things, then either block the pipeline, or maybe you can run that as a scheduled scan that's running every hour or whatever. So you can run this tool in different places. But the point here is this is a blocking and high severity thing. If this bucket does become public, then we can block on these things. Obviously, you can still be running Chekhov and it has some other checks, but maybe the other checks would not be blocking. And same, let's say for SAMGRAP or your SAST tool, they have a lot of checks that they are running. But my point is, maybe you can run these things and just have alerts from them. But the ones that should be blocking are the ones that are related to a mitigation. So the ones that are related to something that you care about in your threat model. So this is another example where you can customize your security tool to cover a mitigation. So the key point here is that it's not about the tool. So you may be using security tools, you may be using unit tests, you may be using integration tests, you may be using something else. The point here is you start from the mitigation and you select the tool, which again could be a security tool or could be anything else. But as long as you're covering the mitigation with proper test, this is really what you should be worrying about. So again, now in our threat model, we can add these tests as part of the process. And again, this would be one of the outputs of our threat model. And again, you'll see that in the sample threat model in Notion that that I've shared the link in the event for. Okay, so let's go lastly to some key takeouts. So what we can take and apply today or in the near future in our organizations from what we have discussed today. So first of all, if you are not doing threat modeling, you need to start planning how you can introduce this to your software development lifecycle. And this is not straightforward. It takes time. You need to have your developers convinced. You have your leadership convinced. You need to have enough people trained. So this takes time, but it does add value. So you need to think about a plan. Sometimes it will take a few months. Sometimes even will take more than that. But start moving in that direction. If you don't do threat model, if you are not doing threat modeling in the design phase of your at least bigger projects, start having a plan or creating a plan to do that. The other thing, if you are doing threat modeling, make testing requirements one of the outputs of your threat model. So by the end of your threat model, take the mitigations, prioritize the ones with high impact and likelihood, and create a testing plan, agree who should be creating the tests and what kind of test needs to be created as an output of your threat model. Because again, threat model is not just a document, it should be a complete process like we have seen earlier. Also, if you're not doing threat modeling, you don't need to wait until you're doing threat modeling, because there are common mitigations that are going to nearly always be there. Things like authentication, authorization, input validation, CSRF protection, rate limiting, all of these things are nearly always there. So make that for every project part of your testing requirements. Always make it required for your developers to create tests, or your QA team or whatever, to create tests for all of these things. If they are adding new routes, if they're creating a new service, make sure all of these things are covered by tests. Obviously, threat modeling helps you with the less obvious ones, like, for example, that setup token in Metabase. But again, like at least the most obvious ones, you can always just make them by default part of the testing requirements. Also, prioritize the mitigations that are more likely to get broken in the future, like specifically the ones that are in your code. So like, again, the setup token in Metabase was written in the code. So the things that are related to the code and the configuration files the developers are usually changing, these are the ones that you should be prioritizing because they are more likely to get broken in the future. And lastly, make the threat model the source of truth for your service, because obviously no threat model is complete, but you can always have a feedback loop back to your threat model. So if you run a CEST scan, a DAST scan, get a pen test finding, a bug bounty finding that wasn't there in your threat model, add it as a threat in your threat model. So make it a live document, add it as a threat, the fix for this finding, make it a mitigation, and now add a test for this mitigation as well. So if you fix a pen test finding, if you fix a bug bounty finding, add it to your threat model and add a test for it as well to make sure it doesn't get broken in the future. And lastly, again, select the right tools that can cover your mitigations. Don't start with the tools, start with the mitigations, the things that you're expecting to see in your application, and select the right tools, because sometimes you would need a tool that covers a specific mitigation, a specific framework, a specific library. So you want to make sure before selecting the tool that it does cover the mitigations that you are expecting. So that's all what I had. I've added a link to my LinkedIn and also my blog in the event itself. Yeah, and I think we're at time, so maybe we have a few minutes for Q&A. Thank you.
There you go. Cool, lovely. Thank you very much. I didn't unmute you as well. Cool. We had one question in the chat regarding the CIA as in confidentiality, integrity, and availability as one of the metrics to build some sort of plan. Could you maybe dive a little bit into the relationship between threat modeling and the DevSecOps sense and how the CIA triad will help?
Yeah, sure. So like there are multiple ways to do threat modeling, and obviously there are like different goals. And CIA is like one of the things, like you just want to make sure you're ensuring confidentiality, integrity, and availability. But there are other things like Stride, for example, which extends it a little more. So we're looking at things like the actual attacks on CIA. So again, we don't have time to actually to go into like the actual or the full details on how to do threat modeling, but at the end of the day, the goal of threat modeling is to define security, and this could mean things related to confidentiality, integrity, availability, but also sometimes it means other things. Like for example, let's say for this file upload service, what if someone tries and uses this to keep some malware and then sends links to users to target these users with this malware? This doesn't really target our own CIA, but it is still like it affects security in a sense. So CIA is just one way kind of to look at security, but it's not the only way to look at it. So I would I definitely like recommend looking at like more literature or more guides on how to do threat modeling and what kind of attacks. And obviously, threat modeling is a muscle that you need to build. As the more you do it, the more things that you discover. And again, like I have this series about threat modeling in my blog, which discusses this in more detail. I don't think we have time for it now, but you can definitely refer to that. But there are books about that as well, like Adam Shustak's one, which even describes it in a much better way. So yeah, but again, CIA is one of the goals of security, but it's not the only way to look at it.
Got it. Thank you. Adit, you had a question as well?
Yeah, Mohamed, thank you for the presentation. Very valuable information. Like I learned a lot. I'm sure everyone who will see this will also get to know a lot of new stuff regarding. Obviously, threat modeling is very important in every aspect of security, but specifically for applications. I had a question actually regarding the how would an application security engineer ensure that threat modeling is conducted, consistently and regularly throughout the entire SDLC process, because it might tend to lose along the way if quality assurance and DevOps or they're not working together. Like how would how would an application security engineer ensure that the process is more?
That's a very good question, and I think this depends on the organization and the team that you are on, definitely. But what I would say is, as application security engineers, we always need to integrate ourselves with the engineering team, because most probably engineering teams and development teams already have their own SDLC process. Like let's say they are using specific tools, specific templates, they have specific gates. So it's usually more efficient for us to see what they are already doing and adding our stuff to it than introducing a new thing. So let's say they have their own like they always start, let's say, from user stories and they review that at a point, and this then is added to their like planning or whatever. Getting involved at this phase is usually the best approach, because now you see what they are doing and now they will see that that's how the normal process works. Okay, and now we can ask them as an extra requirement, if the project meets these criteria. Let's say if you're introducing new backend routes, if you're handling new types of data, whatever, you can add some criteria. If that happens, you need to maybe reach out to security and have a discussion whether this needs to go through a security review, whether we need to create a threat model for it. So again, they probably are using a tool or probably already using a template that you can just add your stuff to, depending on their own like project planning tools. If not, again, working with the engineering leads, the senior engineers, the managers, and so on, is usually the best approach, because it highly depends on the organization and the team and so on.
Sounds good. Thank you. Appreciate it.
Cool.
Fine.
Thank you. And Mo, I had a question. Like coming from an engineering background, I always think in engineering tools. Okay, so I think unit testing, I think a coverage tool to tell me how good my tests are. Is there some sort of coverage system structure process for threat models regarding my application? Is there something where I can get a percentage indicator of how well I've covered my app?
That's a good idea. So There is no tool right now that I know of. This is just like an idea that I had. Now, the way that I'm doing it today is I'm using that Notion template that I've shared for these things, and now the tests are are being added as part of the document itself. And now it's probably just a little more effort to add to actually do like a mitigation coverage metric there. I don't have that yet, but I have it in my plan to add it in the Notion template itself. But obviously not everybody is going to be using the same template. Threat modeling is one of these things that maybe you start with using somebody else's template, but then usually as you do it more and more, you have your own opinion, and you start using your own template or your own tool for it. So it depends on what you're using to document your threat modeling. But the point is, keep that in mind when you are selecting the tool, that you want to have a tool that makes it easy for you to track this. So you want to have the mitigations, map them to tests, and then map that to maybe the status of the test. Is it complete and running today? And hence maybe have that metric, like the percentage of mitigations being covered. Make sense?
Okay, so really specific to your application. And at the moment, I would say a little bit manual in terms of like calculating a number, so to speak.
Exactly.
Got it. Okay, cool. I think that's it for my question. Let's see if Arden is reconnecting. I guess we still see a spinner for him, but that's okay. So let's conclude here. First of all, Mo, thank you very much for your session today. I hope you enjoyed it as much as we did, and I hope we get to see you again in the future session. For anyone watching, and please drop by Discord, drop the questions in our channels. We all hope you enjoyed it. Yeah, Arden, you're back. Fantastic.
Yeah. Thanks for having me. I definitely did enjoy it, and yeah, and if anybody has any questions later on, I think I'll keep an eye on Discord. But yeah, again, I wanted to thank everybody involved in this, and I hope you found it useful.
Lovely. And we will announce the next session shortly. Will be happening also at the end of next month. And in the meantime, for anyone watching, if you enjoyed it, please continue to share the session, and we'll see you next time. Thank you.